We've evolved on the planet Earth, and so we find it a congenial place. But just next door is Venus, until recently enveloped in mystery. It has almost the same size and mass as the Earth. Might our sister world be a balmy summer planet, a little warmer than the Earth because it's a little closer to the sun? Are there craters, volcanoes, mountains, oceans, life?
The first person to look at Venus through a telescope was Galileo in 1609, but all he could see was a featureless disk. And as optical telescopes got bigger, that's all anybody could see. A disk with no details on it at all. Venus evidently was covered with an opaque layer, thick clouds concealing the surface. For centuries, even the composition of the clouds of Venus was unknown. I mean, you could go outside, look up, see Venus with the naked eye, observe sunlight reflected from the clouds of Venus. What were you looking at? What were the clouds made of? Nobody knew. As a result, imagination ran riot. The absence of anything you could see on Venus led some scientists and others to deduce that the surface was a swamp. The arguments, if we can dignify such a phrase, went something like this. I can't see a thing on the surface of Venus. Why not? Because it's covered with a dense layer of clouds. Well, what are clouds made of? Water, of course. Therefore, Venus must have an awful lot of water on it. Therefore, the surface must be wet. Well, if the surface is wet, it's probably a swamp. If there's a swamp, there's ferns. If there's ferns, maybe there's even dinosaurs. Observation, you couldn't see a thing. Conclusion, dinosaurs. Well, if just looking at Venus was so unproductive, what else could you do? The next clue came from early work with that, a glass prism. An intense beam of ordinary white light is made to pass through a narrow slit and then through the prism. The result is to spread the white light out into its constituent rainbow of colors. This rainbow pattern is called a spectrum. Think about it. White light enters the prism. What comes out of the prism is colored light. Lots of colors. Where did they come from? They must have been hiding in the white light. White light must be a mixture of many colors. Here we see the spectrum running from violet, blue, green, yellow, orange to red. Since we see these colors, we call this the spectrum of visible light.
The sun emits lots of visible light. The air is transparent to it, so our eyes evolved to work in visible light. But there are many other frequencies of light which our eyes can't detect. Beyond the violet is the ultraviolet. It's just as real, but you need instruments to detect it. Beyond the ultraviolet are the X-rays and then the gamma rays. On the other side of visible light, beyond the red, is the infrared, again real, again invisible. Beyond the infrared are the radio waves.
Now, this entire range from the gamma rays way over there to the radio waves all the way over here are simply different kinds of light. They differ only in the frequency. They're all useful, by the way, in astronomy. But because of limitations of our eyes, we have a prejudice, a bias, a chauvinism to this tiny rainbow band of visible light.
Now, a spectrum can be used in a simple and elegant way to determine the chemical composition of the atmosphere of some distant planet or star. Different atoms and molecules absorb different frequencies or colors of light, and those absorbed or missing frequencies appear as black lines in the spectrum of the light we receive from the planet or star.
Each and every substance has a characteristic fingerprint, a spectral signature, which permits it to be detected over a great distance. As a result, the gases in the atmosphere of Venus, at a distance of 60 million kilometers, have been determined, their composition has been determined from the Earth. It's amazing to me still. We can tell what a thing is made out of at an enormous distance away without ever touching it.